There is a fundamental contradiction between the appearance of Saturn's moon, Mimas, and the reality hidden beneath its battered crust. To any observer looking at the raw images returned by our deep space probes, this object looks like the very definition of a dead world. It is grey, heavily cratered, and appears to be frozen solid. It shows absolutely no surface signs of the geological life we look for in the cosmos. No active cracks, no towering geysers, and no shifting plates. Visually, Mimas is famous for only one thing: its uncanny, almost haunting resemblance to the Death Star from Star Wars. The surface is dominated by the Herschel Crater, a massive impact scar that stretches a staggering 1/3 of the way across the moon's face. This feature, named after the moon's discoverer, William Herschel, gives the moon a distinct, almost artificial quality. It looks less like a natural celestial body born from the chaos of the solar system, and more like a constructed object or a piece of ancient, metallic debris left in orbit by a long-gone civilization. And because of this battered, static appearance, astronomers spent decades comfortably classifying Mimas as a geological fossil. We assumed it was nothing more than a solid, inert block of ice that hadn't changed in billions of years. This assumption made perfect sense at the time. In our frantic search for life or liquid water, scientists focused their billion-dollar eyes on moons that looked active worlds like Enceladus or Europa, which physically scream their secrets into space by shooting water plumes high above their surfaces. Mimas was largely ignored because it looked too thick, too broken, and too old to hide anything of value. And however, recent analysis has proven that this ancient surface is effectively a mask. New data processing from the Cassini mission, led by Planetary scientist Valery Laney and his team, has confirmed that Mimas is not a solid block of ice at all. Despite that dead, weapon-like exterior, the interior is pulsing with activity. Specifically, this artificial-looking moon is hiding a global liquid ocean, roughly 20 to 30 kilometers beneath its shell. While alternative explanations have been explored, current models favor a subsurface ocean as the most consistent interpretation of the data. This discovery completely overturns the standard model for what a habitable world looks like. We are not looking at a frozen rock. We are looking at a candidate stealth ocean world, disguised as a piece of space debris. The first cracks in this dead world theory appeared not in the ice, but in the heat. In 2010, the Cassini spacecraft conducted a flyby of Mimas to map its surface temperatures. Scientists were not looking for anything unusual during this scan. The expectation was standard for an airless, frozen body. They predicted the temperature would peak near the equator in the early afternoon and smoothly drop off as the moon rotated toward the poles or the night side. It should have looked like a soft, predictable, fading gradient of heat. The data returned by Cassini's composite infrared spectrometer showed something entirely different, something that looked more like a glitch in the software than a natural phenomenon. Instead of a smooth transition, the heat map revealed a sharp, high-contrast shape dominated by distinct boundaries. The warmer region was shaped exactly like the 1980 seconds video game character Pac-Man. This shape appeared to be eating the Herschel Crater, creating a bizarre visual that initially left the mission team in a state of confusion. This anomaly occurred because the surface of Mimas is not uniform. The Pac-Man shape represents a drastic difference in surface texture. The warmer yellow and red areas on the map correspond to regions where the surface retains heat well, while the cooler blue areas lose heat almost instantly. This property is known as thermal inertia. On Earth, we experience thermal inertia with materials like concrete or rock, which stay warm long after the sun goes down. Sand, on the other hand, loses heat very quickly. Mimas showed a split personality in this regard. The leading face of the moon acts like a solid rock, holding onto heat, while the rest of the moon acts more like fluffy powder, losing heat rapidly the moment it rotates away from the sun. The cause of this texture difference adds to the strange, battered nature of this moon. As Mimas orbits, its leading hemisphere plows through a stream of high-energy electrons trapped in Saturn's massive magnetosphere. These electrons bombard the ice on the leading side, effectively welding the powdery grains together into solid, dense blocks of ice. This process hardens the surface and gives it high thermal inertia, while the shielded areas remain powdery and loose. This creates a sharp divide on the surface that is invisible to the naked eye, but glaringly obvious in thermal imaging. It reinforces the idea that Mimas is a heavily weathered object, battered not just by asteroids but by the invisible radiation of its parent planet. Before the discovery of the ocean, this thermal signature was just another oddity that made Mimas seem like a frozen, battered relic rather than a dynamic world. It highlighted a surface that had been subjected to intense external forces for billions of years, effectively distracting scientists from looking deeper into the interior. To understand why we were so easily fooled, we have to look closer at the Herschel Crater itself. It is the defining feature of Mimas, but it is not simply a surface scar. It is a physical record of a collision that almost destroyed the Moon entirely. The crater stretches roughly 130 kilometers across, while Mimas itself is only about 400 kilometers in diameter. This means the crater dominates a full third of the Moon's face. To understand the sheer scale of this violence, you have to compare it to our own home. If a similar impact occurred on Earth, the resulting crater would be larger than the entire continent of Australia. The impact was so violent that the physics of the event are visible across the entire globe. When the asteroid struck, it did not just excavate the surface, it sent massive shock waves traveling through the very heart of the Moon. These waves raced through the center and converged on the exact opposite side of the Moon, a point called the antipode. On that opposite side, the surface is shattered. The ground is buckled and broken into deep canyons and fractures, known as chasmata. This damage was caused solely by the focused energy of the Herschel impact, passing through the Moon and pushing out the crust on the other side. This creates a picture of a world that is fractured all the way through. The structure of the crater itself is immense, with walls rising 5 kilometers high and a floor that plunges 10 kilometers deep. In the center, there is a massive peak that stands 6 kilometers tall, formed when the ground recoiled instantly after the impact. This structure is preserved perfectly because there is no wind or weathering to erode it. For decades, this extensive damage supported the theory that Mimas was solid ice. A liquid ocean usually dampens shock waves because fluids absorb and disperse energy differently than solids. The fact that the shock waves traveled so efficiently suggested the Moon was frozen solid through to the core at the time of impact. This adds a layer of complexity to the recent discovery. It suggests that the Moon was likely solid when this impact happened, and the ocean we see today is a much newer development that formed after this near-fatal collision. The true discovery of the ocean inside Mimas was not made by looking at high-resolution photographs of the surface, but by analyzing the precise, almost musical way the Moon moves. Astronomers used data from the Cassini spacecraft to track the rotation of Mimas with extreme accuracy. They focused on specific craters on the surface and measured their positions over time to see if the Moon's rotation was perfectly steady. It was not. Mimas exhibits a specific type of motion called libration, a subtle oscillation or wobble that happens as it orbits Saturn. Because Mimas has a slightly elliptical orbit, its speed changes as it moves closer to and further from the planet. This change in speed causes the Moon to rock back and forth slightly on its axis. Every moon in an elliptical orbit does this to some degree, but the size of that wobble is determined by the internal structure of the object. When scientists calculated the expected vibration for Mimas, they used a model of a solid ball of ice and rock based on the mass and size of the Moon. There is a physical limit to how much a solid object can wobble. The gravity of Saturn acts on the mass of the Moon to keep it relatively stable. If Mimas were solid, the connection between the crust and the core would be rigid. The entire object would have to move as a single unit, which requires a massive amount of energy, keeping the wobble small and subtle. But the data returned from Cassini showed a wobble that was physically impossible for a solid object. Mimas was rocking back and forth twice as much as the models predicted. This magnitude of movement indicated that the outer shell was not rigidly attached to the heavy core. The only way to explain such a large oscillation is if the icy crust is physically detached from the interior. This creates a scenario where the outer shell is free to slide around independently. For the shell to slide, it must be floating on something. It requires a layer of lubrication that breaks the friction between the ice and the rock in planetary science. The only material that can exist in this layer and perform that role is liquid water. This motion provided the smoking gun. It proved that the ice shell is decoupling from the core and slipping over a global ocean. The wobble is the physical signature of a hidden liquid layer that allows the surface to move with much more freedom than a solid rock ever could. The existence of a liquid ocean inside Mimas presents a massive physics problem. Mimas is a very small object, only about 400 kilometers wide. 2. In planetary science, small things cool down very fast. Any heat left over from its formation billions of years ago should have dissipated into the cold vacuum of space a long time ago. By all standard calculations, Mimas should be a cold, dead stone, For water to remain liquid, there must be an active power source continuously generating heat to keep it from freezing. The source of this energy is gravity. Mimas does not orbit Saturn in a perfect circle. Its path is slightly elliptical, meaning it has an eccentric orbit during each loop around the planet. The Moon moves closer to Saturn and then drifts further away. This constant change in distance creates a dynamic gravitational environment. When Mimas is at its closest point to Saturn, the massive gravity of the planet pulls hard on the Moon, physically stretching it into a slight oblong shape. When Mimas moves to the further part of its orbit, the gravitational pull weakens, and the Moon snaps back into a more spherical shape. This cycle happens during every single orbit. This continuous stretching and relaxing is known as tidal flexing. It is a mechanical process that works effectively, like bending a metal wire back and forth. If you bend a wire repeatedly, the metal at the bend point gets hot due to internal friction between the atoms. The same thing happens inside Mimas. The rock and ice in the interior are grinding against each other as the Moon changes shape, and this internal friction generates a significant amount of heat. Because the heat is generated deep within the Moon, it radiates outward from the core, melting the bottom layer of the ice shell. Over millions of years, this process has created a global reservoir of water between the rock core and the ice crust. What makes Mimas unique is how it handles this heat. On a moon like Enceladus, the tidal heating is so intense that it cracks the shell and vents heat into space through violent geysers. On Mimas, the heating is more subtle. It is strong enough to melt the ice, but not violent enough to fracture the thick outer shell. The 30-kilometer thick ice crust acts like a heavy thermal blanket, trapping the heat inside the Moon and allowing the ocean to exist without giving away any thermal clues on the surface. It is a perfectly sealed system, powered by the immense gravity of Saturn. In the study of Saturn's vast kingdom of moons, Enceladus has always been the gold standard for ocean worlds. It is effectively the loud neighbor of the solar system. It makes its presence known in the most obvious and spectacular way possible. Enceladus shoots massive plumes of water, vapor, and ice particles, hundreds of kilometers into space, from deep cracks in its south pole. These geysers are so powerful that they actually create one of Saturn's outer rings. Because of this, we have known about the ocean on Enceladus almost since the Cassini spacecraft first arrived. The evidence was visual, violent, and undeniable. Mimas, however, represents the exact opposite end of the spectrum. It is a stealth ocean world. It orbits in the same system and is subject to similar gravitational forces as its neighbors, but it keeps its secrets completely contained beneath a mask of ancient ice. Mimas does not have tiger stripes or fissures venting into space. It does not resurface itself with fresh, reflective snow as Enceladus does. Instead, it maintains a heavily cratered, battered face that looks completely dead to the naked eye. The difference lies in the sheer thickness of the containment layer. On Enceladus, the ice crust at the South Pole can be as thin as 1 to 5 kilometers, which is thin enough for internal pressure to break through and vent material into the vacuum. Mimas, however, has a much heavier lid. The ice shell on Mimas is estimated to be between 20 and 30 kilometers thick. This is a massive, dense barrier that suppresses any internal activity. The pressure from the ocean below simply isn't sufficient to crack through such a deep layer of ice. This thickness explains why Mimas fooled astronomers for over a century. We spent decades operating under a specific bias in our search for life. We looked for surface signals. We assumed that if a moon had an ocean, it would show signs of it on the outside, smooth plains, cracks, or plumes. Mimas has none of these. It proved that you can hide a global ocean completely effectively beneath a battered surface, forcing a re-evaluation of how we categorize moons. Enceladus is likely the exception, while Mimas may be the rule. There could be dozens of stealth ocean worlds in our solar system that we have dismissed simply because they look like dead rocks on the outside. The most shocking detail about this hidden ocean is not just that it exists, but that it appears to be brand new, based on the computer models used to analyze the orbital mechanics. Scientists estimate that this ocean is likely only about 15 million years old, in the context of a solar system that is 5 billion years old. 15 million years is effectively yesterday. It suggests we are looking at a world that has only just woken up. The primary evidence for this youth comes from the preservation of the surface. Ice is not like rock. Over long periods, it behaves like a very slow-moving fluid, especially when warmed from below. This process, known as viscous relaxation, would have softened the outer ice shell if the heat had been present for billions of years. Gravity would have naturally pulled down the high walls of the craters and flattened the deep basins. Yet, the Herschel Crater remains sharp, jagged, and deep. Its walls still stand 5 kilometers high, proving the ice shell remained extremely cold and rigid for almost the entire history of the Moon. The interior must have been frozen solid when the impacts occurred and stayed that way for eons. The orbital dynamics support this timeline as well. The tidal heating that powers the ocean comes from the eccentricity of the orbit, but this process consumes energy over hundreds of millions of years. This energy transfer usually corrects the orbit, turning the path into a perfect circle and stopping the heating. The fact that Mimas is still in a highly eccentric orbit suggests this interaction started recently. The system hasn't had enough time to use up that orbital energy. This paints a picture of a solar system that is still evolving. Mimas spent billions of years as a dead block of ice until a relatively recent gravitational interaction kicked it into this new path, igniting its internal engine. But this reclassification represents one of the most significant shifts in planetary science. It forces us to abandon the idea that we can judge a celestial body by its cover. For the history of space exploration, we followed the geysers. Now, Mimas has proven that methodology is fundamentally flawed. A world can look like a frozen, battered artifact and still harbor the conditions for life just a few kilometers beneath the dust. Ultimately, this discovery breaks the traditional definition of the habitable zone. We were taught that liquid water requires a specific proximity to a star to exist, the Goldilocks region. Mimas proves that gravity is just as capable of creating a habitable environment as sunlight. It demonstrates that a world can generate its own heat in the freezing darkness of the outer solar system purely through orbital mechanics. This opens the number of potential habitable worlds significantly. We no longer need to look only for Earth-like planets, but for any moon caught in a gravitational tug-of-war. The implications extend far beyond Saturn. If Mimas can hide a global ocean, we must question everything we know about the other, small, icy moons. We have written off moons orbiting Uranus or Neptune that sit in similar environments. Until now, we ignored them because they look solid. Now, they must be considered prime candidates for stealth oceans. We effectively have to go back and check our work on dozens of objects we previously categorized as space debris. This changes how we design future missions. FS, a simple camera flyby, is no longer sufficient, but to find the truth, we need to feel the planet move, measuring gravity and the subtle wobbles of libration. We used to look at the solar system and see a few rare oases of life amidst a desert of dead rock. The reality is likely far more profound. We are looking at a system where the water is simply hidden from view, tucked away in the most unsuspecting, battered corners of the sky. Mimas is not an anomaly. It is the prototype for a new class of living worlds that we are only just beginning to see. Would you like me to research other moons in the outer solar system that might be candidates for these newly discovered stealth oceans?